Hello, this is Dr. Oz again. Last class we were talking about product mix problem, and today I would like to talk about the sensitivity analysis based on that problem. So in the product mix problem, again, we built our model. We had three different types of products: tools, desks, and tables. And we had capacities for three different types of department: electronic department, assembly department, and packaging department. And we had demands for each type of product: 360, 420, and 300. And we had different profit margins: 30, 70, and 52 for each of these products. And of course, when you look at these profit margins, someone may think that, why don't I produce office desks because they give me the highest profit? But once we run our model, we realize that we don't produce any office desks. The reason is that we have certain constraints in this problem that will stop us to produce office desks. Okay, so now once I run my model, I would like to do sensitivity analysis to learn more about this problem. Again, it's a product mix problem, but this product mix problem could be used for different companies, for, let's say, producing burgers or producing monitors or whatever it might be, right? So it doesn't have to be desks and chairs and stools and so on. So let's look at sensitivity analysis. In sensitivity analysis, I have two parts. The first part is the variable cells, which are related to my decision variables. And the second part is regarding to my constraints, and which are these are corresponding to my 7 constraints listed here. Right? So let's look at the variable cells, or the first table. First thing I see here is the final value. So these values here show me how many should I produce. So my model is telling me that I need to produce 250 stools, 0 desks, and 25 tables. And if you remember, these numbers are exactly the same as the numbers that we calculate in our Excel file right here: 250, 0, and 25. All right, so we know these are the values of the decision variables. And these ones right here are my coefficients. In this case, I'm trying to maximize my profit. So these are the coefficients, profit coefficients right here: 30, 70, and 52. And if you look at it, 30, 70, and 52. These are my objective function coefficients. In other words, for this problem, these are profit margins. All right, so let's look at the reduced cost column. If these values are 0, if I get a 0 reduced cost, it's irrelevant, which means that I have a final value, so that I don't really need to decrease or increase, for the maximization problem increase, for minimization problem decrease my objective function coefficient. For example, currently I am producing 250 stools to maximize my profit, right? And I'm making $30 from each of those stools. So I don't need to increase my $30 profit margin for stools to produce, because I'm already producing them. So this is irrelevant. Whenever I see 0 here, that's irrelevant. But in this case, for example, I do not produce office desks. Although the profit margin is 70, still I do not produce anything. So to be able to start producing office desks, I need to increase my profit margin from 70 to something more than 70, to 80, at least more than $86. So if I increase this one from 70 to, let's say, 70 plus 87 would be 157 or more, then I would start producing office desks. But now at this level, based on these constraints and these profit margins, it's not really logical for me to produce any office desk. Okay, so in other words, these coefficients, excuse me, these coefficients tell me that these reduced cost values tell me that I need to make my objective coefficient at least this much better to be able to produce that product. All right. So if you want to quickly test this, let's test this 86, right? Let's put $90 more. So if I want to test it, I could just change the objective coefficient here. This is just a test to show you what I'm saying is correct. Let's say if I add $90 more, now my profit margin is 106. I would just color this so that I won't forget that I changed this value. And if I rerun my model again here, I just want to show you what would happen. I need to hide this first. Okay. So if I rerun my model without changing anything, you will see that I will start producing office desks. I was not producing any, now I start producing it. Okay. So, but if I don't increase that much, then I will not really see the change. So let me just undo this change and rerun my model. Rerun my model. As you see now, still I produce 0 office desks. So let's test one more time. Again, you are not expected to do these changes, but I'm trying to explain to you how I can understand what's happening here. So let's say instead of 70, if I change my profit margin from 70 to 150, so I increase by $80 more, which is less than 86, then I do not expect my solutions to change. So let's say I change this value from 70 to 150. Now I'm curious what's going to happen. All right. So let's run my model again. As you see, my solution did not change as I expected, because that increase in profit margin of $80 for office desk is not enough for me to change my production mix. All right. So let's go back to the original model. I don't want you to get confused. I just want to show you some scenarios here. Okay. All right. So this is my original solution. Right, so that's what it means. I need to increase or decrease. I need to make my objective coefficient better by this much at least, so that my final values will start changing. If I increase, as you see, the objective coefficient by less than $86, my production mix won't change. All right, so also we need to look at allowable increase and allowable decrease. This means that these reduced costs are going to be this exactly same within these boundaries. For example, if I increase my objective coefficient for stools, currently I'm making $30 per stool. If I increase this value from 30 to 30 plus up to 30 plus 74, which is 104, still I will see reduced cost 0, which means that I will still produce stools. It won't change anything. And if I decrease this coefficient by infinite, then I will start. Still, I won't see any problem with my reduced cost file. So my reduced cost will not change. All right. So these are the boundaries again for the reduced cost. And if you look at the second table, you can see the final values here of the constraint. So you can see the left-hand side values. These are exactly the same as left-hand side and right-hand side values. These are exactly the same as the ones that we have here. 250, 2100, 2500, 17, 364, 2300. You can see those values right here. And then these are the left-hand side values. So this is how much available to us, like capacity or constraints, right-hand side. These are how much we use. And you can see here, if left-hand side and right-hand side values are the same, we call them binding constraints. For example, I was expected to produce 250 stools, and I'm producing exactly 250. That means that this is a binding constraint, okay? So so it is important to understand the binding constraint. And so why am I producing exactly 250? Because I know that that's a requirement, that I have to do that, right? Another example here is electronic hours, less than or equal to constraint here. If you look at the original problem, 2100 is the less than or equal to constraint. So I can use up to 2100, and as you see here, I'm using everything here, all 2100. But these are binding constraints. But this is not a binding constraint, assembly hours. The reason is that I had 2500 assembly hours available for me. I'm only using 1700, so I have an idle capacity of 800 capacity. All right, so this is not binding. So since these are not binding constraints, as you see, their shadow prices are zero. Okay, since these are not binding, their shadow prices are zero, so they are not bottlenecks in my system. But if I look at, for example, electronic hours used, my capacity is 2100 hours, and I'm using all of it. So this 13 means that if I increase the right-hand side value of electronic hours used constraint by 1 unit, I will have my objective coefficient to go better or increase by $13. So every hours of extra capacity that I get for electronic hours, since it's a bottleneck, I will increase my profit by $13. If I look at the another binding constraint, which is number of stools produced constraint, in this case, if I increase this constraint by 1 unit from 250 to 251, then my objective function, which is maximize profit, will go down by 74. So my objective function value will get hurt if I increase my right-hand side value here. Okay, so that shows me the problem here. So, but these values, these shadow price values, are true within this boundary. For example, I could decrease my right-hand side value for stool by 68.75 units, or increase it up to 12.5 units. And within this boundary, per unit of increase, I will observe my objective function to go down by 74. Per unit of decrease, I will see my objective function value of increase of $74. Okay, so same thing for here, for example. If I increase my right-hand side value for electronic hours up to 100, so decrease up to 100, so from 2100 to, let's say, 2050 or 22,000, and every unit of decrease will hurt my objective $13. And I could increase this value by up to 366, so up to 2,466 units, and every unit of increase would increase my objective function, which is profit, by $13. Okay, so if I give an example here, let's say if I increase my right-hand side value here by 100, right? Increase 100, increase right-hand side value, then my objective function value will, my objective function 100 increase right-hand side, then my objective function value will increase by 100 times, right? If I increase 100 units times 13, so I would have $1,300 more profit, right? So if I decrease my right-hand side by 100 units, let's say, it will be $1,300 decrease in my objective function. So that's how we calculate. Let's do another example here. For example, if I increase, let's say this time decrease, let's see if I can decrease up to 68. Let's pick a number less than 68. Let's say 60. 60 decrease in right-hand side, my objective function will, right, if I decrease it, increase by 74, right? 74, but it's negative. So if I decrease it, means that negative, which is positive. times 60. So my objective function value would increase by $4,400. Okay, sounds good, because I'm decreasing every unit of decrease. I know that will increase, since it's negative, negative is positive, increase my objective function by $74. So my result will be increasing by 4,440 in addition to what I have. So another thing I would like to show you is that if I give you a screenshot of this, you could basically calculate the objective function, which is maximize profit. So you could calculate your objective here, which is maximize profit, by again multiplying your coefficients by your decision variable. So my coefficients are right here and my decision variables are right here. So if I do some product trick, you can calculate exact same dollar value here as well. Okay, so this is good. So this value is exactly the same as the value that we got here. So you can see that again one more time. If I decrease my right hand side for still produce constraint from 250 to 190, then my objective function will increase by 4,440. So it currently is 8,800 plus 4440, which will be $13,240. And another example here, if I increase the right-hand side value from 2,100 to 2,200 for electronic arts capacity, somehow, let's say if I hire more people and ask them to have overtime and so on, I could increase my objective function by 1,300 from 8,800 to $10,100. I hope this helps, and enjoy supply chain management.